This is the first topic in business analytics. This is just going to be a very quick overview of some of the main concepts in business analytics, and then the rest of the course, all the different topics, are going to get much more into the details in terms of the content of it. But this is very, very, very big picture, things that we want to have in the background of our mind as we work through this. So one of the things that we want to talk about is the scope of what this course of business analytics could cover. So there are three main types of analytics that we're going to talk about. For most of what we're going to do in this course, it's going to focus on these first two of descriptive and predictive analytics. So those are two that go hand in hand pretty easily, and then prescriptive analytics we're going to get to towards the end of our topics. Descriptive analytics, you can see there, use of data to understand what's going on, right? So we've got it's a data-based system. All of this, the things that we look at in analytics are going to be focused on empirical questions or data questions. So we're going to use information, data, quantitative information for the most part, and we're going to use it in a couple of different ways. We can either use it to understand what's been going on, and again, our focus is on business analytics, and so our focus is on what businesses have done, and again, to the point of making good informed decisions. Or we might want to put our future-looking hat on and say, all right, what's the future going to look like? Based on some data, we can look at some historical trends, some patterns, some relationships, and we can say, moving forward, what is a variable going to look like in the future? And so there's this really hand-to-hand relationship between descriptive and predictive analytics that's pretty straightforward. Prescriptive analytics is a little bit different though, right? So what prescriptive analytics looks at is we're trying to achieve something. We have a goal in mind and we're trying to achieve it, and we're using data to try to figure out the best way to achieve our goals. Our goals can either be to maximize or minimize some objective. In terms of what we're talking about there, maybe your objective in working through this material is trying to maximize your grade. Right? Well, there's a whole bunch of things that can influence your your grade, the amount you study, the amount of time that you put in reading the textbook, the amount of time you put on the every topic's assignments, the amount of time that you put on learning terminology, the amount of time that you put on working through some of the questions at the end of a chapter. There's many different things that you can do that can try to influence your grade. And so maybe you might want to look at some patterns or some relationships in the data to understand which of those different combinations of things you could do is the best combination that will not just achieve a certain grade, but rather will maximize your grade, right? And so that type of action is what we call prescriptive or prescriptive analytics, yeah, right? So we can think the main source of prescriptive analytics that we're going to be looking at in the end of this class has to do with marketing analytics, right? And so when you think about promotional activities, there's a lot of different ways that a company could advertise or market their products or their services. There's a lot of different ways, a lot of different mediums that they could use to try to advertise. What's the best way that they should advertise, right? And so that, again, you got to have some data to try to figure out the best way to advertise. All of those kinds of questions would fall under the prescriptive story. So we've got some longer explanation of these. Descriptive analytics, yep. Again, some good typical, I'm not going to read these, but the typical questions that we could ask. Again, notice on the focus on the time frame of this. How many products did we sell? Did, past tense. How was our revenue? Was our revenue, right? With a lot of descriptive analytics, it's very much looking to the past and using data to understand what has happened in the past. That's different from predictive analytics, which notice the types of questions that those, what will happen if, what do we expect? And so with predictive analytics, it's very much a forward-looking perspective with the types of questions that we ask. I'd like to call out one of the tools that we're going to use, regression analysis. So my background, I'm an economist, and so regression is one of the main tools that economists use in their research. And so this is the most natural place that I talk about analytics from my academic background is with regression analytics. Right, but again, very much we're going to spend a fair amount of the class going through different topics that are going to lay out the story of regression and some of the things that we can do with that. But again, we can use regression to understand past historical patterns, but it's also a very useful tool to think about what's going to happen in the future. And we have some other tools that we're going to look at. Again, lastly, for this prescriptive analytics, where we've got to think about some sort of goal that we have in mind and how we would achieve that goal, some of the factors that would influence those goals, right? Fundamentally, this is a story about optimization, and so we're going to work through some of the main terminology and some of the main things that we need to focus on when we're doing optimization, and we're also going to focus on how we would carry that out. Again, in this class, Excel is going to be the main tool that we use to understand how to carry out these different types of analytics. Again, some questions: best price, advertising strategy to maximize revenue. How do we minimize cost? Again, what's our goal? We're either maximizing or minimizing, factors that influence it. The foundations of business analytics is really data, right? Data forms the foundation of business analytics. Businesses have been around for centuries, right? We've been having people buying and sell stuff, and it's become more sophisticated, more evolved through time. But really, this is a long-term thing that's been around as part of human culture, right? Is the idea of business. And data? What is data? Data is just information, right? And so have businesses, buyers and sellers, been using information? Yeah, they've been doing this for centuries, right? But why is there this new interest in this thing that we're calling business analytics, right? And so part of it is the changing and evolving nature of data through time. Businesses have access to more and different kinds of data in different ways, and they're using that in additional ways to help them make good decisions. And that's really what business analytics is, right? It's the use of quantitative data to help businesses make good decisions. And so you may have heard this term big data recently. One of the nice ways that I like that people have described big data, and that's somewhat of a buzz term that gets thrown around a lot, but I think that these 4 V's really capture a lot of the characteristics of this thing, this nebulous concept that we call big data, right? And again, we've had data for centuries. It's just what's new about the way that data is and the way that data could be used that we have this extra emphasis on this term business analytics and the term big data. Number one of those is the volume, right? Is just the volume of data that's being generated and captured is so much different in the past, right? So again, this is probably second nature to you, but you all more than likely have smartphones or know someone who has a smartphone, and you generally know how those things operate. And just stop and think for a second about how you use your smartphone for just a 5-minute window, right? The amount of information that's being collected, the number of sites that you go to, the number of apps that you open, the amount of time that you spend on each of them, all of that information, right? It's being collected in a way that it was not collected in the past. Sometimes I like thinking about, as a good example, news, right? We've been getting news and information about the topics of the day for centuries, right? We've got the printing press and we've got newspapers. So it used to be that a newspaper would get delivered to your door, and you may or may not read through that newspaper. Now, right, with a smartphone, there's a whole lot more information that's being collected about your news consumption. Just the volume of that information that's being collected is happening on a scale that just wasn't decades ago. The variety of information that's being collected. Again, if I think about the old school, you getting a paper newspaper, you have this paper newspaper. How long do you spend reading a single story before you move on to the next story? That information, that wasn't being collected, 2 decades ago, even a decade ago, right? But now with smartphones, the ability to see how long someone spends on an app or a page of information, just that variety of data. It's not just the amount of data, but the variety of data that's also being collected. The velocity of data. What do we mean by the velocity, right? Velocity is related, it's this physics term, right? But it's related to this idea about how quickly information can be acquired and processed. In the past, right, if we were going to do a survey about people's news consumption, that would have taken a long time to put those surveys together, to send them out to the public, to collect that information, to get it submitted in. I remember when I was doing an undergraduate and I did actual paper survey, and just the amount of time that it took to get that information back, whereas today, online surveys are so much quicker. That's what the velocity is getting to, is the speed with which information is able to be collected, communicated, and analyzed. It's just changing dramatically the veracity, right? So I mentioned half a second ago that I had done some surveys as an undergraduate. How truthful was that information? Whereas, how truthful would people be about a survey about how long they spent reading the international section of their newspaper? Whereas, if we just look at the data from their smartphones, we may get a much more accurate accurate portrayal of what the underlying information is for the amount of time that people are engaging with those topics, right? The veracity. That's what it's getting at. That last V. So really, it's not just the size, it's not just the variety, it's not just the speed, but it's all of these things together that have changed so dramatically over the last few decades. That's really what we're calling this big data revolution. And so if we think a little bit futuristically, though I say futuristically questionably because a lot of this is already being done, right? I mentioned mobile data. You are more than likely statistically familiar with social media at this point, and just the amount of data that's being collected. Those are some interesting things. We also have path data. So if you're taking a business analytics class, you may have an interest in marketing, and marketing is using this a lot, right, with the promotion, the analytics. And so we've got a nice little picture to illustrate how marketing is important. So it's got something that we know already, as well as something that we can apply data to. So they've got, it's a little difficult to see, but we make this argument. Oh, I can't zoom in on that guy. We make this argument that those black bars there are grocery aisles. And so if you think in red, the path of individuals is in red that individuals are going up and I'm doing it in yellow, up and down the aisles, that's simply not at all the way that a customer goes through a grocery store. Instead, those end caps are so important because consumers, when they're going actually traveling through a grocery store, they often don't get to the middle, right? And so end caps have a higher premium to that shelf space, so to speak, right? I mean, we've known this for a long time about the way that grocery stores are, but now, right, we can use a lot more geocoding data to try to track the way that people are actually moving this path data of people's physical movement or their eye movement in terms of where their eyes are falling for different places. All of these things, right, have allowed the amount of data that can get into marketing and promotions to just explode. And again, futuristic, but actually a lot of it's already being done. We want to talk about 4 different types of data, right? So there's a couple of different ways that we can slice and dice data, but there are 4 main ways that we can classify data. So we've got the term categorical data, ordinal data, interval data, and then ratio data. Let's start with the first one, categorical data. Categorical data, or sometimes referred to as nominal data, is data that quite simply can be sorted into categories. That's the end of the characteristics of this data. So I've got a little map here to to the right of this where it's got the different states in the US organized by different regions, right? The West, the Midwest, the Southwest, Southeast, and the Northeast. Those different regions are categorical. That's it. Why? Because we can take those states and we can sort them into categories, but that's it. That's the end of it. And to help us understand what categorical data is, let's real quick talk about ordinal data. Ordinal data is similar in that it represents different categories, but those categories can be ordered or ranked, right? So I've got an example here of, I can't remember when this was, but this was the women's NCAA from, I can't remember if it was February, January, something like that. And where we've got different categories. The ranking here is what we call the ordinal data. There's a ranking here, and there's clearly that the different categories of first, second, third, fourth, fifth, they imply something, right? Whereas first is a category that is better than second, which is better than third, which is better than fourth, right? Whereas with regions, is there a clear ranking to the regions? Right now, there's just different regions that states could be classified as. Whereas ordinal, there are different categories, and those categories can be ranked. Another good example of ordinal data has to do with educational attainment, right? So some of the main categories that you'll often see in data are high school or less, some college, or advanced. Think about people that you know, and I'm thinking about older people that you know. They're going to fall into one of these categories, aren't they? But also, these categories, we can rank them in some way that's meaningful, that would represent higher levels of educational attainment. You're only an individual, a single individual who would represent an observation would only fall into one of these categories, and those categories, there's clearly a category that is its highest and a category that's its lowest. That is what ordinal data represents. Ordinal data, it's categorical data with a ranking. Interval data. Thirdly, interval data. So interval data, there's a constant difference between observations with an arbitrary zero. My goodness, what does that mean? Think about temperature. Temperature, and I'm thinking about temperature on the Fahrenheit scale. What's temperature measuring? Right? It's measuring something. But we also know that the numbers indicate something about how comfortable it is outside, right? You can think about what's the difference between 30 degrees and 60 degrees. I mean, intuitively, you understand what the difference feels like. But if we just step back and say numerically, right, 60 is a number that's twice as big as 30. Does that mean that you'd say that when it's 60 degrees outside, that it's twice as hot as it being 30 degrees out? That makes no sense whatsoever, right? Though we can say that the 30 to 40 degrees is a 10-degree difference, and that's equal to a 10-degree difference between 60 and 70 degrees. We've got this idea about there being some sort of equivalence between variables, but there's an arbitrary zero. Zero means nothing, right? And again, so when I compare these values to 0 degrees, 30 degrees above 0 versus 60 degrees above 0, would you say that 60 degrees above 0 is twice as hot as 30 degrees above 0? No. Why not? Because 0 means nothing whatsoever, right? Temperature is a great example of an interval data. We can do things with interval data, but our main focus is going to be on ratio data. Ratio data is continuous data that has what we call a natural zero. Natural zero means that there is not an arbitrary zero, right? So this is, we can think about people's income. So if we have two households, one household that has income of $40,000 and another household that has household income of $80,000, can we say that the $80,000 household has twice as much income? Sure they do, right? And again, it's because relative to 0, they are twice as far from 0. 0 means something. That's what ratio data is. Ratio data is a continuous variable that has a natural 0. So I numbered these as 1, 2, 3, 4, right, as if there was a progression between them. And to some sense, there is, right? We've got continuous with a natural 0 all the way back to number 1, where we had not a continuous but discrete variables where the categories didn't have a ranking. In that sense, there is an element of hierarchy to these different types of data. We can also think about the terms quantitative versus qualitative data. You may have heard this before, but just as a quick reminder, we've got some different examples of quantitative and qualitative data. So take a quick look at those, and then we can think, what are some things that determine whether something's quantitative or qualitative? So it looks like the stuff on the left, the quantitative stuff, what does it look like? It looks like it's got numbers to it, right? 16 ounces of coffee, temperature of 150, cost, right? We've got some numbers. It looks like quantitative information has some numbers associated. Qualitative, Robust aroma. Oh, white cup and white lid? Maybe. I like the taste, even though I think it's a little bit strong. So quantitative data looks like it's more numbers based, right? But I think what a better defining characteristic is, with quantitative data, you could have two different individuals looking at the same piece of information and they would draw the same inference, right? So if we had a cup of coffee, this is my terrible drawing of a cup of coffee, and we asked two people to measure how much liquid was in that cup of coffee, they could both take it and they could both measure it and find that it was 16 ounces. That's quantitative in that it's numbers based, and two different individuals looking at it would come to the same conclusion. Whereas qualitative, if you had a cup of coffee and you had two different people and you asked them, does it have a robust aroma? Those two different individuals may not agree on that piece of information as to whether or not it did or did not have a robust aroma, right? So qualitative data is useful. Again, think about if you've got a marketing background, a lot of these things are really, really, really important to you in terms of marketing, in terms of promotion, in terms of how you do that, the placement, all of these kinds of things. Qualitative data absolutely has its place. Our focus here is going to be more on quantitative data. And in your further marketing classes, if you ever take them, you're going to bridge the gap between these quantitative and qualitative things so that you can kind of see the value of both of those, or try to find a way to make qualitative information into a more quantitative metric. Unit of analysis. So we're going to talk about this a few different points throughout this class, but we want to always think about, whenever we think about data, one of the useful things to think about is what are we talking about, right? So if we're talking about a company, we may be talking about products, and each of our line of data may represent a different product. We might be thinking about a government information where every line of data represents a state or a county or something like that. Or we might be looking at a bunch of data on consumer behavior where each line of data represents one individual person or one individual household, right? So oftentimes we are going to be looking at a data set, and usually that's going to be in Excel. And we want to think about, what do each of those rows represent? What is the unit of analysis that we are using for our observations? So I wanted to add that terminology right here, and then we'll come back to practicing it a few different times throughout these topics. More types of data. Hopefully you remember these from an earlier statistics class or mathematics class. Cross-sectional data, time series data, or panel data, right? So when we're talking about cross-sectional data, I've got this picture to hopefully jog your memory about what cross-sectional data is. What do I have? I have a bunch of different companies. So if I had an Excel worksheet and I had a bunch of different lines and each of the different rows represent different companies, and I was looking at their profits, that would be cross-sectional data, right? Because I'm looking at one single variable, profit, across a number of different companies, all within a given time period, say their profitability in 2017. That's different from time series data. Time series data, and this is a little difficult to read, but it looks like this little graphic is Cardinal Health's year-to-year stock price. Looks like it goes back to 2017. This is for the year 2017. So it's following who? It's following one single entity, Cardinal Health, through time. It's looking at their stock price. We're looking at one variable through time. That's what time series variable is, right? So again, just step back and think about, what are the differences between cross-sectional and time series data? Cross-sectional, we're following a variable across a number of different units of observation. Time series data, we're following one entity, whether that be an individual, a company, a government, a state, or whatever, but we're following one entity with multiple time periods. Right, so again, think about what time series would look like if we had it in Excel. we're going to have a bunch of different rows, and all of those different rows are going to represent different time periods. And the one column would be Cardinal's stock. That's time series. Our different rows represent different points in time. Whereas with cross-sectional data, our different rows represent different companies. Panel data is a combination of these two, right? So what we've got is this is the relative stock performance of, so again, Cardinal Health in red, in blue, the overall healthcare sector, and then in green, the overall S&P 500. So what are we doing, right? I've got a time component to this. It absolutely is following through time, but I'm not just following one single piece of information. Rather, there are 3 different series that are being followed. Cardinal Health, the healthcare sector, the S&P 500, right? With panel data, it's in a sense a combination of cross-sectional and time series, right? Where we're following a number of different units, but we're following them through time. 2 terms we want to introduce, reliability and variability. And so hopefully these schematics help you think about what reliable and valid mean in our very, very specific context that we're meaning, right? So you may have heard the term whether something's reliable, valid, precise, or accurate, and you may use those in everyday language in a way that's not exactly correct, right? But in this class, we want to talk very, very carefully about those terms. So we could think about, right, the way to interpret this schematic. Think about the bullseye here as representing the truth. And let's let each of the black dots represent data measurements that are trying to get at that underlying truth. So you could think about, if the truth is the true temperature outside, those data measurements could be if we sent a bunch of thermometers outside, and each of those black dots represents a measurement, a data measurement from a different thermometer. Right? So, okay, let's focus on some stuff. We've got 1, 2, 3, 4 of these to talk through. Number 1, reliable, not valid. Notice the pattern of the black. Number 1, is the pattern of the black very spread out, or is it very, very concentrated in a single area? Looks like this, relative to the other ones, is pretty concentrated. There's not a whole lot of variability. But notice, is that concentrated area actually hitting the right sweet spot, the truth? No. So it's very, very concentrated, but it's not in the right spot. Number 2, we've got our black dots. How spread out are they? My goodness, they are all over the place, right? There's a big spread to the black dots. However, on average, where are the black dots centered around? Looks like they're centered around the right spot in the middle. There's a big amount of variability, but they are on average going to be in the right spot where the truth is. Over here, what do we got? Now we have a combination of the two, right? It looks like the data is pretty spread out, and where's the center of these black dots? It's not where the truth is. There's a big spread to our data, and the center is not where the truth is. And then lastly, we've got a very, very close pattern of our data, so there's not a whole lot of variability in our data, and the center of that data right where the truth is, right? So that's what the pattern is. Now let's add some terminology to it. So that first one, where we had a very, very tight fit to our data, but it was not in the right place, we'd say that that is reliable, but not valid. Whereas in number 2, when our data was all spread out, we said it was not reliable. All right, so what does reliability mean? Reliability means how close are each of our data measurements to other data measurements? Are we consistently and reliably getting the same information? That's what reliability means. Notice that reliability and precision we can use interchangeably. But again, number 1, it was reliable, but it wasn't valid. Whereas the second one, all of those black dots were very spread out, but on average, they were centered around what the true underlying piece of information was. Valid. That's what validity is, right? Validity is how, to what degree do our data measurements on average get the result right? Notice that that's the way that we're going to use the term accurate. So precision really refers to how spread out or how close together our data measurements are, whereas accuracy refers to how closely our data measurements are on average getting at the truth, right? We're going to be careful with those terms, and we're going to use them, we're going to try to use them as precisely and as accurately as we can this semester. That was supposed to be a bad joke. Lastly, we're going to look at a couple of different models in here, right? So we just want to introduce this very, very big picture that we've got a couple of different ways that we can look at modeling out information. We've got 1, 2, 3. Actually, yeah, I thought I missed one. So we've got verbal. Oh my goodness. We've got graphical, and we've got mathematical. Those are the three main models that we're talking about. In data analytics, you should be able to transition between these three pretty seamlessly, right? So you're probably a little familiar with something like this, where we've got a horizontal axis and we've got a vertical axis. It looks like this is measuring the amount of weeks, and it looks like vertically we're measuring the amount of sales, and this looks like this is the pattern of sales through time. Okay, and it looks like it starts out slowly, increases, and then starts tapering off. Here we go. In words, the rate of sales starts small as early adopters begin to evaluate a new product that begins to grow at the increasing rate over time as positive customer feedback spreads. Eventually, the market begins to become saturated and the rate of sales begins to decrease. Right? Both of those things are telling the same story, but one of them is telling them that story in a much more easier to understand way, in that visual. Can you go from the visual to the words? If I gave you the words, could you go to the visual? Can you make that interchange between a graphical and a verbal presentation of information? Really, that's all that a model is, right? Is some kind of abstract presentation of some information. We also are going to deal with some mathematical models where we're dealing with some equations, some but not too many equations, hopefully. Right? So actually, this little curve that describes this pattern of sales through time, it would also be described by this equation of sales as a function of a couple of different parameters. Okay, don't worry. We are not going to be doing most mathematical models. Will be a little bit more simpler than that. We've also got, we want to talk about, before we leave this topic, influence diagrams. So real quick, if you think, pause for a second and think about what all this influence diagram is telling you. Later in this class, we're going to be talking about some data visualizations and just in general some good visualization techniques. One of the good visualization techniques should be that it's designed clearly enough so that it can communicate the right amount of information to whoever your audience is. Think about, what is the point of this diagram? What is trying to be explained by it?